All right, so in this video, we want to find the shortest distance between this point and this curve over here. So you want to start with just doing a quick sketch of the situation. It doesn't have to be accurate, but over here we can tell that this over here is a sideways parabola because the x and y are switched from a regular parabola and it's positive. So it's going to look something like this. We have a sideways parabola. Again, the vertex is not accurate, but it doesn't have to be for this sketch. Then we have a point over here, -2 and 4. -2 and 4 is somewhere here. By the way, this could be anywhere. This could be here. This could be over here as well. So there could be like 1, 2, or even 3 points on this curve. For example, if the diagram was like this, there's a possibility that these 3 points over here could all be equally close to this. There's a possibility that there's only 2 points like this and this that are close, and then there's a possibility of 1 point like this as well. So it doesn't matter how you draw the diagram, like this or like this, you'll always get the right solution as long as you follow these steps. So first thing you want to do is you want to just label one of the points. You don't have to label all of them if you have a diagram like that, but you just want to label one point over here and call this point as x comma y. And basically, we know this will be the minimal distance. So if we want to find this distance over here, we need to start by writing our distance formula. So we know that our distance formula is just the square root of x1 minus x2 squared plus y1 minus y2 squared. Could be x2 minus x1, y2 minus y1. There's no difference with that. So I'm going to do the square root of x minus -2, which is just x plus 2 squared plus y minus 4 squared. So that's my distance over here of this line. The next thing I want to do is I want to replace my x with this whole thing over here. I'm going to replace this x with whatever's in the question. So I'm going to have the square root of y squared minus 8y plus 18 and then plus 2 squared. And over here it's going to be y minus 4 squared. And then I want to just combine like terms in here. I'll also write the square root as an exponent now. Oops, plus 20 squared plus y minus 4 squared. And I'm going to write this as an exponent to 1/2 because that's going to be easier for me to derive. I want to find the minimal distance, which means I'm going to derive this equation over here. So if I derive this equation, d prime equals. So you might be tempted to expand this out, but don't expand this out because you'll get a y to the power of 4 equation. And then when you solve it, you'll have to solve a cubic equation. So you'll end up doing factor theorem. You'll still get the right answer as long as you don't make any mistakes. But if you want to avoid doing factor theorem and synthetic division, leave the equation like this and just derive it like this. So my derivation is going to be 1/2 times y squared minus 8y plus 20 squared plus y minus 4 squared, and the exponent will become -1/2. And then I'm going to multiply this by the derivation of the inside because of my chain rule. So the derivation of the inside is just 2 times y squared minus 8y plus 20. The new exponent is 1, and then there's a double chain rule here. So this is going to become 2y minus 8. And the derivation of that is just 2 times y minus 4. New exponent is 1, and there's no chain rule over here. So that's my derivation of this function. Now I want to make this equal to 0 and solve because that's going to give me my critical points, which are basically my max and my min. I'll write that as 0, and over here, I'm going to rewrite this a bit more neat. The first thing I'm going to do is I'm just going to move this whole thing to the denominator and leave this in the numerator. So I just have 2 times y squared minus 8y plus 20 times 2y minus 8 plus 2 times y minus 4. And this is going to be all over. I guess I don't need the bracket anymore. It's going to be all over this 2, and then this whole bracket over here, which is y squared minus 8y plus 20 squared plus y minus 4 squared, and then the exponent is going to be 1 over 2. Okay, the next thing I can do is I can just make this whole denominator here disappear, because it just all multiplies with 0. But another thing I want to do really quick before I do that is I want to just cross off these 3 2's, because I can just do that to simplify this equation a bit. So now I'm going to multiply this whole thing with 0. So I'm just left with 0 equals to the numerator, which is y squared minus 8y plus 20 times 2y minus 8 plus y minus 4. I want to factor a 2 out of this bracket, so 0 equals to 2 y squared minus 8y plus 20 times y minus 4 plus y minus 4. And then I want to factor out a y minus 4. 0 equals 2 y, oops, not 2, sorry, y minus 4, 2 times y squared minus 8y plus 20 plus 1. And then I want to multiply this 2 in this bracket, combine like terms here. So 0 equals to 2, oh no, 2y minus 4. Why do I keep writing the 2 there? 2y squared minus 16y plus 40 plus 1. And this is going to be 0 equals y minus 4, 2y squared minus 16y plus 41. So next I want to factor this. What multiplies to 82? It's a complex trinomial, adds to negative 16. I don't believe that's possible. Let's do quadratic equation. Let me check my discriminant really quick. So my discriminant is b squared minus 4ac. So negative 16 square minus 4 times 2 times 41. Let's check what this is. Negative minus 4 times 2 times 41 is negative 72. So my discriminant is negative, which means there's no solutions here. And over here, my solution is y equals to 4. So we know there's only going to be one point that has the closest distance. But like I said, if there was going to be 2 or 3 points, like in these scenarios over here, you would find 3 different solutions here or 2 different solutions here. And that's how you know how many points there are on the curve that have the closest distance, basically, to that point. So y equals to 4 is my y value. I can come back here to the original equation and find my x value by subbing it in here. X equals to 4 squared minus 8 times 4 plus 18. I'll do this in my calculator. And I get the point x value to be 2. So this closest point here is 2 and 4, which means my diagram is actually a bit inaccurate. Okay, but the closest point is 2 and 4. And then if I want to find the distance, I can just do the distance equation for these 2 points. I can basically sub it back, my x and y, into this equation here. So I have the square root of 2 plus 2 squared plus 4 minus 4 squared, which is just the square root of 4 squared plus 0 squared, which is just root of 16, which is 4. So this is the minimal distance, 4 units. This is the point that's the closest. The actual diagram looks like this. So this is a very rare case where the y values are the same, and you can easily tell from this diagram that, oh wait, I drew the diagram wrong. -2, oh yeah, no, I do it right. You can easily tell that this distance is positive 4 units because from -2 to +2. You can't usually tell, but you can estimate from other diagrams as well what the distance is going to be. But I'm going to show you a pretty cool way where you can check your answer over here in this question specifically, but only do this if you have extra time. Do not do these steps unless you've completed your test or your exam and you have extra time to check your answers. So this is the original equation here. We can actually complete the square on this equation. I'll do it really quick. So I've completed the square here on this equation, and now what I can do is I can reorganize this equation. I can do x minus 2 equals to y minus 4 squared. Then I can square root, so plus or minus x minus 2 equals to y minus 4, and then I can add 4. And then by transformations, you can tell here that this equation is basically exactly like this. The vertex of this is going to be 2 and 4. Well, technically not the vertex, but you can tell that it's shifted 2 units to the right and 4 units up. So you could actually check this question and kind of tell. You could check it with other questions that are not even as well, but it would be hard to estimate the distance, but you could kind of do a check and tell whether your solution is approximately correct or not. But again, only do this check if you have extra time, you've completed your test or exam, and you don't have other things to do.